My name is Ian Clark, and this is my interactive advanced concept presentation to the iodine clock reaction. And for this reaction, we're going to be combining two reactants to do a rate limiting reaction, and we'll cover all the steps of it. For the video, my head's going to kind of be cut off because I'm limited on space. But first, we're going to make solution A, which will consist of vitamin C. I had the powder kind. I didn't have the tablet form. So we're going to do 2 grams, which would be the same as 2,000 milligrams of vitamin C. We're going to weigh it out here on the scale into this clear container, and this will be our container for and there we are. All right, for solution A, we're going to add 60 milliliters of distilled water. We're going to stir this around, make sure it's mixed up well. It seems to dissolve a bit better than the tablets would because it's just pure vitamin C. So any of the solids, we're going to strain those out into another clear container, just using a coffee filter. And then for our second solution, we're going to use cornstarch and water, and then we're going to add hydrogen peroxide at the end. This will be strained out in just 1 second and give us a usable solution here. We'll discard the coffee filter. Okay, so solution 2. This will be solution A. Go ahead and make a mark on that so the pen doesn't work. This highlighter will work. A. And then for solution B, we're going to do 0.4 grams of cornstarch, as the video stated. We're just going to kind of estimate from about as much as they did. And then we're going to add 350 milliliters of water. This is a 250 milliliter measuring cup, so I'm going to add 250 and then another 100. Okay, and we're going to stir this up. And to make it mix a little better, I'm going to throw it in the microwave real quick. And as you can see, to get it boiling. That'll just help the cornstarch dissolve a bit better into the water. While that's going, I can go ahead and get set up for the second part of this experiment. So we got our solution A. So when that gets out, we'll add our hydrogen peroxide to solution B, and the solution B will be ready. And then we're going to go ahead, while this is waiting, we have an iodine tincture. It's 2%. And this was the only one I could find in my town. So I'm going to add this to our first solution. And you can see it immediately changed to clear because of the vitamin C. Discard that, and then I'm going to get a larger glass, and we can top this off with about another 250 milliliters of water to get close to 500. So there's our solution A. It's complete. Grab this mixture out of here. It's hot. So we're gonna get another cup or glass here to help strain this. I'm just gonna use a coffee filter, just like on the previous solution. I'll pour this a bit slower so we don't have any spilling going on. Let this strain down. Prop that up there so it drains a little better. And so once this finished draining, I'm gonna add 150 milliliters of peroxide to it. And what's going on here is this is a mixture of two reactants, and it's called a chemical clock reaction, where the concentration of one of the chemical components undergoes an abrupt change in concentration after a time period. The molecular iodine undergoes the concentration change in this one. The first step generates the iodide I negative, and this occurs slowly, and it's the rate determining step. The rate determining reaction, this is the rate determining reaction of this entire reaction, because it's the slowest step and nothing can go faster than this slowest step. So this is slowly, and it's not much clearer, it's a bit clearer. I think it's clogging my filter. So pour that aside. I'm just going to add this back to the cornstarch. It might be a bit cloudy, but we still should get the same reaction. So in this one, I'm going to go ahead and add our hydrogen peroxide to our solution B. I may have to get a larger for this. So let's turn the camera down so we can see a little bit better. I'm gonna go ahead and add this here. So this is our solution B. So we have solution A, solution B. So when we add these together, iodine is going to be produced, and it's going to be quickly oxidized by the iodate ion, and then the iodine is reduced immediately back to iodides by the bisulfite. And this occurs quickly, and the molecular iodine does not exist long enough to react with the starch, and so there's no color change observed until all the bisulfate has reacted. Then the iodine reacts with the starch, and we should see a dark color complex change. And if we wanted to figure out the rate of reaction for this reaction, we would do the time it takes for the dark color to appear when we mix the two solutions. So I'm going to pour a little bit of this one in there, and some of our solution A. And so we should stir these, and if we did this correctly, or if I did this correctly, we should see a change in color. Once the iodine reacts with the starch, but we have to use up all of the bisulfite has to be reacted before the color change can happen. And since my iodine was a bit weaker, is all I could find in town, I'm curious as if this change is going to occur. I haven't seen a color change yet. curious if I pour, let's try more of the iodine mixture, see if that one reacts. Unfortunately, I'm not seeing a change here, and I'm curious as if it was because my iodine solution was not strong enough. As you can see, I had the iodine tincture was only 2%. It's kind of hard to see, and that was all I could find in my town of 4 or 5 stores I tried. So I'm guessing that may be the issue, is there wasn't enough strong enough solution of iodine added to cause a reaction between the bisulfate and iodate. This includes my experiment for interactive concept presentation number 2, the chemical clock reaction.